All right, so 7-8 is called Applications of Matrices and Determinants. So we're going to learn how to use determinants to solve systems of equation, to find the area of a shape formed by 3 points, and to find, to determine if 3 points are collinear. So 3 different applications. So the first is the area of a triangle. If I've got a triangle that's formed by 3 coordinate points, 3 xy coordinate points, then I can find the area by doing 1/2 times the determinant of those 3 points with ones in the last column. So if I had the coordinate point 2, 3, then when I write that in a row, it becomes 2, 3, and then the last column is always 1. If I had the coordinate point 0, -4, then it would be 0, -4. Last column would always be 1. So you'll fill in the first 2 columns with the 3 coordinate points, the last column with the ones, and then we're going to find the determinant. We're going to repeat the 2 columns to the right. We're going to do the diagonals, top left, bottom right, add those up, top right, bottom left, add those up, and then take the first diagonal sum and subtract the second from it. The number you get from that, you will multiply times 1/2 or divide by 2. And then the plus or minus sign at the front is just telling you, you change the sign to make it always positive. Area is always got to be positive. So if your answer from the determinant is positive, you leave it alone. If your answer from the determinant is negative, you multiply by a negative to change the sign so that your area again is always positive. So it's 1/2 the determinant, but then you make it also positive. All right, so it says find the area of the figure with the given vertices. So I don't even want to graph these. I just want to put them into my matrix. So the first row would be -2, 4. Let's spread that out a little bit. Then 2, 3, -1, 5, and then the last column is all 1. So I'm finding the determinant of this, multiplying it by 1/2, and then making it positive in the end. So I'm going to duplicate the first 2 columns to the right. I'm going to work my way on the top left, bottom right diagonals first. So -2 times 3 is -6 times 1 is -6. 4 times 1 times -4 is -4. 1 times 2 times 5 is 10. And then I want to add these up. -6 plus a -4, that's -10 plus 10, that's 0. Then I'm going to come back the other way. Diagonals top right, bottom left. So 1 times 3 times -1 is -3. -2 times 1 times 5 is -10. 4 times 2 times 1 is +8. I get -13 plus 8 or -5. I do the first set of diagonals, which is the 0 minus the second set. So 0 minus a -5 becomes 0 plus 5 or 5. That's the determinant. And then I'm going to multiply it times 1/2 or divide by 2. And I get my area is 5/2 or 2.5 or 2.5 units. If it was negative, I would change it to positive. Because it's positive, I can keep it the way that it is. Alex?
Will we have to put the units on the test?
No. If it gave you the units, you could put it, but I'm not going to mark it wrong without. Take either of those answers, so you could give it to me in that fraction form or in the decimal form. Yeah.
Will we get points off if we don't put units?
No. Mm-mm. Questions? Oh, I got me done. I could go this way, or I could go that way. It doesn't matter which way, as long as you only go one way, right? So let's say I want to find the area of this triangle. I'm going to use those 3 points. So -3, 2, -1, -4, -5, -4. And it doesn't matter in what order those go. I'm going to find the determinant of that. And then if I want to find the area of this one, I would have -3, -2, or sorry, -3, +2, 1, 2, and -1, -4, and then fill in the column of ones. And then at the end, I'm just going to add these together. Diagonal, top left, bottom right first. What did you notice?
So the 1, 2 point, if you were to subtract 1 and -2 on the other points that you get of the triangle, you could actually make it simpler, and you could have a 0, 0 point, and then the other points you could easily cancel out if you multiply.
Oh, you're making it so much more complicated than you need to be.
Wait, really?
Yeah, you can't move the points.
Yeah,
like-
no, because you would just subtract -1.
Yeah, no, I know you're shifting the shape, but you don't do that. Yes, it works if you keep the shape true to form, right?
Yeah.
But you have to shift it in exactly the right spot.
Okay.
Yeah, and you shift 1 point incorrectly and you screw the whole thing up.
Okay.
Yeah. Don't make it more complicated than it needs to be.
Okay.
Yeah. Okay, so I've got the two determinants, right? I got -24 for the first one and -24 for the second one. To find the area, I'm going to multiply them by a half and make them positive. So -24 times a half, or divided by 2, is -12, but I want to make it positive. So the area of that first one is 12. The second one, I'm going to do the same thing, times a half, make it positive. This is also 12. And then 12 plus 12 is 24. Now this is a parallelogram, so they are exactly the same shape. I actually could prove those two triangles congruent using side angle side or side 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 once I find that diagonal. You could do it that way, okay? But they're not always going to be parallelograms. So if you want to make sure it's a parallelogram first and then double your area, that's fine. Just keep in mind that that could have been slanted. Like if I had slanted it further this way, it's no longer a parallelogram, but you could still find the area the same way that we did it, okay? So if it's a parallelogram, you should get the same area for both. But it's not necessarily always going to be a parallelogram. And again, this is units squared. Yep.
For the determinant, does it have to be the first one minus the second one?
Yep.
Or is it?
Like it has to be this one minus this one. Is that what you mean?
Yeah.
The thing about this is it's area, and we make it positive. So we're always changing the sign, so it actually won't matter. But for the true determinant, it has to be the other way around.
Okay.
Like if I just gave you this and asked you to find the determinant, the sign matters. Does that make sense?
Mm-hmm.
Yeah. So as far as like timing goes on your test, I took off the questions that just say find the determinant because you're going to use it this and then Kramers Rule you're going to see in a minute too. So there's not like just a find the determinant. There's a use the determinant to find the area. There's a collinear, which you're going to see next, and then Kramers Rule. So you still have to use it 3 times.
How many questions is it?
I think I have it at like 9 right now. I have to tweak the timing on it. But ish. Yeah. Okay, so then test for collinear is the second way we're going to apply the determinant. So if you think about it, first of all, what does collinear mean?
On the same line.
On the same line. So if I have 3 points that lie in the same line, do I have any area?
No.
No, it'd be a flat line. There's no shape there. Does that make sense? So if my area was 0, then they would be collinear, which is the idea behind this, okay? If you were given 3 points and the question says, determine if they're collinear, the answer is yes or no. The way you get there is finding the determinant. If the determinant is 0, then it's a yes. If it's anything other than 0, it's a no.
So you don't multiply by 1/2 anymore?
Nope.
It's just finding the determinant.
You're just finding the determinant. So you're going to get the 3 points. You're going to fill the last column in with the 1s. You're going to find the determinant. If it's 0, it's a yes. And if it's not, it's a no. So it just says determine whether the points are collinear. I do know that if you had a graph, you could just plot those points and determine if they make a straight line. That's not what you're trying to do here. The question on your test, it will actually say find the determinant and then determine if they're collinear. So it's going to force you to do it that way. So I would do -2, -2, 1, 7, 5, 1, 1, 1, 1. Duplicate the first 2 columns, -2, 7, 1, -2, 5, 1. Top left, bottom right diagonals first. -10, -2, +7, -12, +7, -5, and then back the other way. 5, -2, -14, 3, -14, -11, and I get -5 minus a -11, which becomes +6. Is 6 0?
No.
No, so these are not collinear. Easy stuff, right? Just gotta be really careful with your signs, especially when duplicating those columns. Like that's when people make the most mistakes, or the math in your head. Okay, last one is the application of Kramers Rule, okay? So just when you think you can't get enough of determinants, you will find you can, okay? The determinant you can use to actually solve the systems of equation. So after this method, we would have learned substitution, elimination, graphing. What am I missing? Matrices using Gauss-Jordan and Gaussian elimination of substitution. And now Kramers Rule is the last way we're going to learn to solve a system. So if I have a two-variable, two-equation system, then I'm going to find the determinant of, I'm going to find three. I'm going to find the determinant when I remove the x's and replace them with the constants. I'm going to find the determinant when I remove the y's, replace them with the constants. And I'm going to find the determinant when I use the x's and the y's. So these here, like if I want to find, I will actually call this, we'll call this d sub x. This would be d sub y. And then the bottom one is just d. Okay? And the way this works is when I'm finding d sub x, if I were to look at my original, if I take this and I put it into matrix form, these will obviously all be numbers. I get that, but I want to take them two at a time. So for the d sub x, I actually remove the x column and I put in the constants. For d sub y, I keep the x's and I remove the y's and I plug in the constants in its position. And then for just d, I keep the x's and the y's. To find the x value, I'm going to do d sub x over d, and to find the y value, I'm going to do d sub y over y. All right, let's look at this. All right, so directions say use Kramers Rule to solve this system. First thing I'm going to do is rewrite this in matrix form. So this is 2, -3, -11, 1, 2, 12. These are my x's, my y's, and my constants. So when I want to find d, I do the x's and the y's. 2, 1, -3, 2. When I do d sub x, I want to take out the x's from that matrix and put the constants in their place. So -11, 12, -3, 2. And then I want to find d sub y. To do that, I take the original one, I switch the y's out for the constants. Now I'm going to do my little Jesus fish for all three of these. So this would be 2 times 2 minus 1 times -3. 4 minus a -3, which is 7. Go to the next one. Same order, 2 times -11 minus 12 times -3, -22 plus 36, which is 14. And the last one, 12 times 2 minus 1 times -11, 24 minus a -11, which is 35.
Are they always going to go in evenly, or are we going to get fractions?
You could get a fraction. I would say you could probably get a fraction, like maybe on the 2 by 2, but I'm going to try to keep it easy on the 3 by 3 and make them whole numbers. Yeah. At least the original ones are like that. Like I haven't gotten to makeups, but at least the original ones are like that. All right, so then x would equal d sub x over d, and y is d sub y over d. So this is 14 over 7, which is 2, and this is 35 over 7, which is 5. And your solution is a coordinate point, so it looks like it, 2, 5. All right, you do it. All right, so for d sub x, you should have got negative 16, d sub y, 32, and d negative 16. X is the d sub x over d, or negative 16 over 16, which is 1. Y is d sub y over d, or 32 over negative 16, which is negative 2. And then you should have gotten 1, negative 2. Questions? What do you think comes next? 3 by 3. So you do exactly the same thing, except you're doing a 3 by 3 matrix every time you're finding the determinant. So you will not have a question that says find the determinant of the matrix and it's 3 by 3, because you will have these that are applications of them. So like if you think about it on your quiz, I gave you a 3 by 3 and said just find the determinant. I gave you a 2 by 2 and just find the determinant. Those are going to be eliminated because you're going to use them in these processes. So Kramers rule, to find D, you take the X's, the Y's, and the Z's. So the first 3 columns. D sub x, you take out the x's and you put in the constants. D sub y, you take out the y's, put in the constants in that column. And then D sub z, you take out the z's and you put in the constants in that column. So be careful, because you're not always replacing the same column. You want to replace the one that you want to find. So D sub x, I take the x's, which is going to be in the first column, and replace them there. All right, so we're going to work through this one. It says use Kramers rule to solve. All right, so this one, I'm first going to make my system from it. So my x is negative 2, my y is 1, my z is 0, and then my constant is 1. My x is 1, my y is negative 1, my z is negative 2, my constant is 2. My x is 3, my y is 1, my z is 0, and my constant is 6. Be really careful, because you lose a sign there and everything from here on out is wrong. So now D by itself is the x's, the y's, and the z's. Negative 1, or negative 2, 1, 0, 1, negative 1, negative 2, 3, 1, 0. And then I'm going to come back and do that determinant. D sub x. I take out the x's and put the constants in its place. So 1, 2, 6, then 1, negative 1, 1, 0, negative 2, 0. D sub y, take out the y's this time, so I go back to the original x's in the first column. The y's are now taken over by the constants. The z's are the same. And the last one, D sub z. This time x's stay as x's, y's stay as y's, and the constants go in the place of the z's. So for the first one, I'm going to duplicate the column. Negative 2, 1, 3, 1, negative 1, 1. Diagonals, top left, bottom right. 2 times 1 times 0 is 0. 1 times negative 2 times 3 is negative 6. 0, 1 and 1, 0. Go back the other way. 0, negative 1, 3 is 0. Negative 2 times 2 is 4 times 1 is 4. 1 times 1 times 0 is 0. And I get negative 6 minus 4, negative 10. And that's D. Then I go to the next one. Duplicate the first 2 columns. Top left, bottom right first. 0, negative 12, 0. Go back the other way. 0, negative 2, 0. And I get negative 12 minus a negative 2 becomes negative 12 plus 2, or negative 10. That's D sub x. Negative 2, 1, 3, 1, 2, 6. Top left, bottom right first. 0, negative 6, 0. Work your way back the other way. 0, positive 24, 0. And I get negative 6 minus 24, negative 30. Last one. Top left, bottom right. get 19 minus a negative 1, which becomes 20. So now x is d sub x over d, y is d sub y over d, and z is d sub z over d. So d sub x is negative 10, d is negative 10, that becomes 1. D sub y is negative 30 over negative 10, that becomes 3. And d sub z is 20 over negative 10, that's negative 2. And your answer, coordinate point form, 1, 3, negative 2. So your test will give you like what is d sub y, d sub z, all of that. So you can get partial credit. You just got to be careful, obviously. But if you screw up one of them, it doesn't mean all credit is lost. You just got to make sure you show your work.
Once you screw up D, then you're screwed.
Well, yeah, but I'll still give you points for d sub x, d sub y, d sub z. You just won't get the overall answer. Yeah. So it will kind of baby step you through it. Find me those 4, then find me the x, the y, the z.
Can you zoom in on Z?
On z? Yeah, sure. So I would say, obviously, that if you had to choose and it's a 2-variable, 2 equation, now you've got elimination, substitution, graphing, Gaussian elimination, back substitution, Gauss-Jordan, or this. I would probably go with elimination, okay, if you had the choice, right? But the 3x3, they're all long. Whether it's the new 1, new 2, or the Gauss-Jordan, or the Gaussian elimination, back substitution, or this, they all tend to be a little bit long. I don't care if you have extra time and you want to check it a different method. But in order to get credit for these questions, you have to do the determinant method. So you have to do the way that it's asking you to do it.
You just plug them in.
Why are there so many ways? Like, did they get bored?
Sure.
So they just kept,
I guess so.
like, finding it?
Yeah. Well, maybe Kramer wanted to be famous. So he's like, I'm going to come up with my own method. Or he's like Connor and's like, hey, I figured something out. I'm going to try this differently. I don't know. I don't know how they came about.
Well,